Question number 29. Again, we see an acceleration graph, but the important thing is to notice that acceleration is now not relative to force, but relative to time. So this is a change in acceleration with time, which means that the force, since it's only one object, that means that the force is changing. We see an increase in force and thus an increase in acceleration. In 2 seconds, acceleration grew from 0 to 3 meters per second squared. And then within one next second, it dropped back to 0. And from 3 to 4 seconds, we have 0 acceleration. So the easiest part, because they want us to translate into a graph fx versus t. So I prepared, so this will be our fx in newtons and time in seconds. So like I said, from 3 to 4 seconds, we have 0 acceleration, which tells us that there's 0 force. So I'm going to grab this and get me 0 from 3 to 4. There is no force applied to the object from 3 to 4 seconds. From 0 to 2 seconds, we see an increase in acceleration, therefore an increase in force. If mass equals 2 and acceleration equals 3, then force at this moment in time, at 2 seconds, should be 6 newtons. You multiply mass times acceleration. So then I'm just going to say from 0 to 2. And I'm just going to claim that this right here is 6 newtons. Then within the next seconds, it drops from 6 newtons all the way to 0. And then finally, it is here like that. So the graphs look very similar. The only thing that changes is if I were to look at the value, I go from 0 to 3 for acceleration, but that's from 0 to 6 for force, because you multiply acceleration times mass.